I try to imagine a fellow smarter than myself, and then I try to think, what would he do?
Charge up your axons, ready your receptors, and shift your lobes into upper beta phase. You are listening to Smart Drug Smarts, the podcast dedicated to helping you optimize your brain with the latest breakthroughs in neuroscience, nootropics, and psychopharmacology.
Hello and welcome to Smart Drug Smarts. I'm your host, Jesse Lawler, excited to bring you the 85th episode of this podcast dedicated to the improvement of your own brain and cognition by any and all means at your disposal. This is a kind of a special week for me, and I won't know the results of how special it is or isn't because all these things need to be tabulated, but a couple of interesting things are going on. Tomorrow I'm going to be getting a blood test, and after almost 3 months of eating an incredibly high amount of fat in my diet and spending, I'd say, probably a good 2/3 of that time, probably popped out of ketosis every now and then, but I've been deeply in ketosis for a good probably 2/3 of the last 3 months. I'm going to get my blood chemistry run and see what all this has done to me. And then after that, I'm going to start reintroducing some fruit into my diet because it's summertime. There's a lot of good fruit to be eaten, and I got to say, I've been sort of jonesing for it. But coming down the pike, there's going to be a ketosis and cognition episode. We've got a great expert. He's been harpooned. We've been waiting a while, but it will be worth waiting for. But this week, we're talking about something completely different. We're talking about biohacking and supplement design with Abelard Lindsay. Abelard Lindsay, you might remember from an earlier episode, long ago, back in the 20s. Abelard, which is not his real name, by the way. His real name is Justin, but he's got a sort of a pin name in the Nootropics world, Abelard Lindsay. But he's been biohacking for a long time. A couple of years ago, got a lot of attention for developing the stack now known as Siltep. We had a Siltep episode prior to this one, and Abelard is also the father figure and designer behind the two products that we just launched last week under the Axon Labs label, Nexus and Mitogen. We're going to be talking specifically, we're talking sort of generally about Abelard's background, his process, his own sort of biohacking ethos, and then also the specifics of how Mitogen came about, what made it in, what didn't make it in, and the details of this particular stack, which I should point out is actually in my system right now and pretty much has been ever since the bottles arrived. But that'll be in the main interview. If you hang around until the very end of the episode, I'm going to tell you about a behavior typically associated with crazy people that can actually be a very, very good cognitive hack. That'll be in the Ruthless Listener Retention Gimmick. But first, let's kick things off, as usual, with This Week in Neuroscience.
Smart Drug Smarts. This Week in Neuroscience.
So some interesting and I dare say good news for aging brains coming out of the University of Cambridge and Medical Research Council's Cognition and Brain Sciences Unit, who have given us reason to believe that the human brain actually changes less than we have previously thought as it ages. Now, it's long-standing folk wisdom and backed up by neuroscience that brains don't function quite as well as they get older. And particularly in what are traditionally the last decades of life, this downslope can be pretty extreme. But most of what we've been able to see scientifically over the past couple of decades has been changes in standard brain activity based on functional magnetic resonance imaging, fMRI studies. And what researchers are now finding is that some of these differences are actually not necessarily related to neuronal activity, but instead these studies have sort of been misinterpreting vascular changes, blood flow changes, for neuronal changes. So traditionally, fMRIs have been looking at changes in regional blood flow, and this blood flow is definitely something that changes as people age. But research done as part of the CAMCAN project, headed by Dr. Kamen Svetanov, is causing scientists to believe that some of these changes are vascular, not neuronal in origin. They've got a method based on resting state fMRI measurements that they think can be used as a robust correction factor to control for vascular differences in fMRI studies of aging. So if this is accurate, it could mean revisiting a lot of older data about aging brains and possibly giving reason for some less gloomy outlooks about changes in the neuronal activity of brains as people age. Says Dr. Svetanov, there's a need to refine the practice of conducting fMRI. Researchers should make use of available resting state data as a suitable alternative. Our findings clearly show that without such correction methods, fMRI studies of the effects of age on cognition may misinterpret the effect of age as a cognitive rather than a vascular phenomenon. So probably not surprising, in the listener feedback, this past week probably had an order of magnitude more direct communication between me and Smart Drug Smarts listeners than any week in history, which has been great. It's been exhausting, but in a good way. The launch of the Axon Labs products last week had just a bevy of questions and enthusiastic responses. Questions about what countries we ship to, or, oh shit, my country doesn't get shipped to, and why is that? And what about this ingredient? And what if I'm on this particular medication? And I guess really all the kind of things that a person should should expect when you are launching a supplement line. But since this is my first time launching a supplement line, some of it caught me off guard, some of it was stuff that I expected, but nevertheless, just a very, very, very busy week. If anybody has sent an email to me and is still waiting on a response, gosh, I think I've cleared the decks at this point from all emails up to about 24 hours ago. But if you've waited longer than you feel like you should for a response, A, I'm very, very sorry. And B, don't feel bad about repinging me on email, jesse@smartdrugsmarts.com. And we actually do have some online helpers in the background at support@axonlabs.io. for some of the more nitty-gritty concerns. But that's been super fun having all these interactions. I really appreciate the enthusiasm from the people that have jumped in early to try out these couple of stacks. One thing that I found fascinating that I really didn't expect is that I got a lot of emails saying, hey, I just made an order. This is my first time trying any nootropics. And I really wasn't aware. We didn't get this information when we did the census a couple of weeks ago. And maybe we just didn't really ask the right questions to tease this piece of information out. But there are a lot of listeners to this show that really aren't nootropics users yet, that I guess are just listening because you're brain fans and cognition fans, and I think that's totally awesome. It really came as quite a surprise to me, but especially for those of you who are just kind of dipping your toe into nootropics for the first time and chose to go with one of the stacks that we just launched, that is a huge vote of confidence, incredibly flattering, and I just can't tell you how much I appreciate that. We've now, not surprisingly, put a link to the Axon Labs website up on the Smart Drug Smarts website. So if you find yourself at smartdrugsmarts.com and you're wondering how to get your hands on these things that we're talking about, the stacks Nexus and Mitogen, there's going to be a shop link in the header bar now. There's going to be a picture of a jar floating around somewhere that you can't help but see. So all that e-commerce stuff should be set up and relatively straightforward. So I'm not going to bang that drum too much. I assume that we are all e-commerce shopping veterans now, used to buying things online now and then. Or to once again throw a big thank you to everybody that made a recommendation this week of, hey, you should reach out to this person, or here's a potential interview subject. That kind of stuff is really helpful. You know, we've only got so many eyes, so many ears, and so many hours in the day. So to get cool subjects to investigate thrown at us from the listener community is really, really helpful. And it's kind of fun to get our eyes open to some of this stuff that we might not find out about otherwise. Got people sending us articles, people sending us books, and luckily somebody just sent me a piece of speed reading software which will help with the articles and the books. Last thing before we move on to the main interview, I would like to formally invite you to sign up for the Smart Drug Smarts mailing list if you are not on it already. I know a lot of you are, but I also know a lot of you aren't. It's an excellent way, I would even say the best way, to keep up on everything that we've got going on both here and on the website, and even some curated stuff that we think is really cool but can't fit into the show. That is normally written by the beautiful and talented Rhiannon Rowe, who is the oft-mentioned guest harpooning power behind the throne, responsible for probably 70 to 80% of the people that we talk with, and 70 to 80% of the cool things that make it into the newsletter. If you go to the website, you pretty much can't miss the sign up, and if you're on a mobile phone and not near a web browser, you can text the phone number 33733 with the text message SDS, and that'll get you signed up.
Smart Drug Smarts.
So our guest this week is Abelard Lindsay, software developer by day, biohacker by night. I kind of think of him as a bit of a brain hacking superhero, partially because he has a pseudonym, but also because he's got like a really encyclopedic knowledge of a whole lot of different chemicals, supplements, compounds. He's the kind of guy that you wouldn't want to mess with on Trivial Pursuit, I don't think. He seems to have a gift for pulling these wildly separated, disparate pieces of information that he got in different places and saying, hey, wait a minute, doesn't this tab A kind of fit into that slot B? And that sort of forms the background of his ability and methodology for the stack designs that he's worked on. So we're going to be talking about his background as a biohacker. We veer off a little bit into weird speculation, futurism for a while in the middle of the conversation, and then bring it back towards the end with the particulars of the mitochondrial stack Mitogen that we just released and that Abelard and I are clearly biased in favor of. But this isn't like one of those situations where somebody has a kid and they're like, hey, look at my kid. My kid's beautiful, right? It's not exactly like that because people don't get to design their kids yet. And this was, if you want to stick with the kid analogy, a kid that we could have built the DNA and the epigenetics any way we wanted, and we did, and Mitogen is what we wound up coming up with. So at the risk of having a self-aggrandizing interview, let's dive in with Abelard Lindsay.
So when I think of a nootropic, I think positive allosteric modulator at like a receptor site, or it's doing something like methylene blue, where it's speeding up the activity of complex 4 in the mitochondria, or it's like an enzyme. It helps things move along, or it improves the property of some component of cellular metabolism or neuronal function. It doesn't go in and just cause a dump of neurochemicals into, the synaptic cleft, for example.
I think that's actually a pretty good definition of something that helps the process along but doesn't have follow-on negative effects. So tell us a little about how you got started as a citizen biohacker, what the process was getting into this world.
Well, it started about 2004. I had always been interested in smart drugs or just the concept of smart drugs. For a while, I was taking phenytonin. There had been this long period of advocacy of phenytonin as a cognitive enhancing drug by someone who I'm distantly related to, Jack Dreyfus. He spent a lot of the first half of his life inventing the modern mutual fund industry. And then the second half of his life, after he took phenytonin, he founded a foundation, spent all kinds of money to fund research into it because it had dramatically positively affected his life. So I was taking this as an anti-epileptic. Got wind of this story, and it just made me more interested in the topic. And so it always had been kind of in the background of my thoughts. And, I think in the early 90s, I had heard some news story about paracetam being studied for cognitive enhancement and people were mentally impaired. And it was just always in the background. And then in 2004, I started studying biochemistry and so forth.
And when you say studying biochemistry, this is fully extracurricular. You've got a job doing other stuff and you're taking it upon yourself to study biochemistry.
Yeah, as a hobby. There were a bunch of old articles by this guy Tolson, who I think you can still find him around on Mind and Muscle or whatever, where he did these reviews of paracetam and aniracetam, and he had a really great style of just putting together all the research and writing these monographs. And so I started off reading those and started taking paracetam in 2004, and it really changed my life. Some people aren't very strong responders to it, but I felt it pretty intensely, and it just became a passion of mine because I had been so positively affected, and I started reading more and more and just really digging into it over the years and becoming a regular on longevity and talking with people and going back and forth about all the mechanisms of action and how the systems underlying all these smart drugs work. And I just kept reading medical studies and kind of accumulating all this trivia and putting it all together and so forth. A lot of people will stay in their various area and concentrate on that and do a lot of research around that. And then there are review articles which are kind of at a higher level, and then some people try and tie that stuff together, and that's what I like to attempt to do. So then I was looking at these phosphatidylserase 4 inhibitor studies and trying to figure out a way to hack that mechanism of action. And that's how the whole CILTEP thing got started. That's been quite an exciting adventure, to say the least. That's been going on for the last couple of years. Last year or two, I've been writing articles and digging into various aspects of cognition and neuroscience and kind of deep diving into those areas and reading a lot of medical studies. And, there's a lot of dead ends, a lot of things, ideas I have don't pan out, or there's no way to really safely exploit them, or there's nothing that is available on the market that has certain properties, or they're prescription drugs or whatever. So it's a lot of going down one pathway, getting stuck, going down the next pathway, kind of a depth first search, if you will.
What's your sort of heuristic for whether something is worth testing on yourself, worth actually doing a biological test rather than just reading about something that might work and then rejecting it?
If I see a study where they say, well, mice gave this to mice and they did really well, that's when I get interested in a mechanism of action. Like the PDE4 inhibitors, they after 24 hours, they had a really strong positive effect on memory in mice, and in learned avoidance, where they would give them like a foot shock if they went into a certain area of the cage, and then whether they remembered that, or freezing when certain tones were played, that kind of thing. And obviously, if there's a human trial and they say, well, this works great, then yeah, obviously. That's sort of the minimum standard for most people in the nootropic world. But then I look at some of these other mechanisms that they haven't been able to develop effective drugs for in humans, like synthetic drugs, because most pharmaceutical companies, understandably, are interested in these synthetic drug targets, and they want to develop something that they can patent and sell. And
do you feel that makes them not look into some of these natural compounds as strongly as they should?
Well, I think that they're in business to develop drugs to make money to sell. So that's just the way they operate, and that's fine. There's a lot of research on natural substances and how they work, and sometimes there's correlations with these drug targets that are interesting or underexploited maybe. That's how I focus my understanding. And then the other thing I do is I try to look for synergies. I try and say, well, okay, so this chemical is doing this here in the body. And so what is it processing? Okay, where does that chemical come from? You get something like acetyl-CoA, which goes into the mitochondria, feeds into the citric acid cycle, powers the cell. Where does that come from? Well, that comes from pyruvate dehydrogenase complex. So what's going on in the pyruvate dehydrogenase complex? Well, we've got CoA coming from pantothenic acid, and we've got thiamine, vitamin B1. They're interacting there, and they're helping to make acetyl-CoA. So what if we did something there by adding sulbutamine and pantothenic acid, and then we did something further down the citric acid cycle, like garlipoic acid, that's participating in citric acid cycle reactions.
This is sounding like some of the ideas that led to Mitogen there.
Right. So you go up the chain of all the way back to food, and then you go down the chain to the actual the neurons firing, strengthening from the transcriptional activators, which are going into the nucleus and telling the DNA to start transcribing proteins that are contributing to growth of the cell, for example. I mean, most people, they look at the drug and they say, what's the evidence on the drug? Or what's the evidence on the nutrient? Like, what do the clinical trials say? Did it move this number that way? And I try and dig into the mechanism of how these systems work. What's the machinery here? I mean, there's a lot of things going on. Body is complicated. How do these little machines work, and where are their inputs, where are their outputs? And then the next machine down the line, what's it trying to do? And every step along the way, can we have a beneficial effect on that machinery?
There's so much research still going on. It's like the brain is sort of the final frontier, I think, of things that we'll be able to figure out. Maybe it's the last big hurdle for us to figure out before artificial intelligence figures out everything else for us.
Just from a totally science fictional kind of perspective, if we're going to be able to travel around like even the solar system, or we're going to have access to a large amount of energy and advanced technology, we've got to kind of get to a higher level of responsibility, otherwise, we're just going to not be able to deal with that much technology. So, I think that everybody becoming, smarter and more perceptive and understanding the world better and their place in it and all that stuff. That's kind of why I do this.
That idea that technology allows one person to affect many in a way that's never been possible before, I think almost requires that in some sense the many become one, that we all recognize that to a very large degree we're all in this together. Because when we have this concept of the other, we're always willing to do pretty terrible things to the other. And to the extent that I think we can use some of our social technologies and our cognitive enhancement technologies to make the feeling of the other less real to people, it keeps us all safer as our technology expands.
I think that there's going to be, over the next century or so, there's going to be a gradual process of just upgrading human consciousness, making ourselves more intelligent. I mean, a lot of people are interested in combining our brains and machines. I'm not the most enthused about that direction. I mean, I think there's something there, but I'd rather work on improving and optimizing our existing biology.
That's interesting to me. I mean, I don't disagree with you, but I'm just wondering why your slant is in that direction, like why the other more man-machine interface doesn't sit well with you.
Well, I mean, I've taken the artificial intelligence at the graduate level and worked with artificial intelligence systems, and I mean, they're only really useful in specific domains. And the other thing is we're always going to be in charge of the cost function. And in these artificial intelligence systems, you have, and supervised learning at least, you have a function that says how good your algorithm is. How well did it do on this image recognition test? How well did it do at classifying spam? And when we humans, we say, oh, good, you classified a spam message, we're kind of saying that is the good, like reducing spam, so we're always going to be in charge of telling the computer it did a good job.
But don't we do the same thing with human children? I mean, at some level, it's like, the kid poops on the floor, tell him he's bad. The kid does something cute, you tell him he's good. It's like, that's a part of learning.
Yeah, that's true. Well, we teach our children, our values and so forth. I mean, different cultures over the history of the world have different values. And that's going to always be the domain of humans. What's funny about artificial intelligence is when you get into neural networks with lots of nodes, nobody really knows exactly how it's reasoning. It's just it does well on the test. And so that's sort of our human culture, our knowledge that's been gathered Well, we're doing pretty well in the test. So, and it all sort of makes sense to us, this collection of practices we've developed as far as achieving the goals that we've kind of mutually come to agreement upon in our civilization. And so I think there's something that's human about that we can't really have computers take over. And people talk about the gray goo disaster of nanotech, where nanotech turns everything into gray goo. And it's sort of like a computer, if you just say like optimize this variable, I mean, it could, if that meant turning everything into gray goo, it would.
When you think about designing an artificial intelligence system, it's almost like designing a governmental entity. Their checks and balances are probably a very, very good thing. You don't want to allow the pursuit of any one directive to just run amok and throw everything else out of whack.
Right. So what is the good? I mean, that is kind of the human aspect of this.
That's a cultural thing, though, that changes over time. You ask somebody now, what is the good for society versus somebody from the 15th century or from, 6 centuries BC, you're going to get some really, really different answers.
I think back to Aristotle, who says, the ultimate good is irrational because they're always the intermediate goods, which are for the purpose of achieving the ultimate good. But the ultimate good is the end in itself. That's sort of the human aspect of this, is what gives us satisfaction in life and pleasure.
The ultimate good, it seems like, reduces the suffering and maximization of pleasure is really all you can get to.
Yeah, and and there's various sort of like a herbal concoction that there isn't solid science behind, but has been developed by like a traditional medical system over thousands of years. It's there's some underlying truth underneath it that works. Through a long period of time and practice.
Yeah, I think that's called the Lindy effect. If something has been around for a long time, there's less likely to be, horrible, devastating, bad things about it that haven't come out in the wash yet. If something's just been invented in the past 5 years, it's like it might have some horrible effect 10 years in that we don't know about. But I guess to go back to a nootropic example, something like ginkgo biloba or bacopa monnieri that's been in use for a couple thousand years, it might not have the efficacy of some of these newer chemicals, but on the other hand, the potential downsides we know to be pretty limited because it's been around forever.
Yeah, and I sort of look at that as almost like a traditional belief system. If a traditional belief system has been around for a really long time, then it sort of has that quality. And while a new synthetic may have better qualities, it's like a newer thing, so you don't know yet what all the side effects are.
An episode that I've been wanting to do for a while is really kind of deconstructing what we mean by the word smart, because we have this sort of childish notion, all of us know what smart means, you get better grades on your test or whatever, but that really breaks down, I think, within our cognitive processes in a bunch of different directions. I read an interesting article recently about somebody who's saying that smart drugs aren't necessarily making you smarter, they might just be improving your motivation to work on things, and the outward effect would be more similar to what a smart person might do, but it's more based on the motivation than the actual cognitive processes. And we can take other examples too. If your mood is improved, you're more likely to be active, and that activity is more likely to have results, and so on and so forth. How do you kind of go about thinking about that when you're looking at things that you can optimize in cognitive processes? Like, what processes stand out to you as being worth optimizing?
I think the difference between smart drugs and stimulants, for example, is that smart drugs, they improve the functioning of a particular system in the mind, or in the mitochondria or the neurons. For instance, the racetams, they are allosteric modulators at the AMPA and NMDA receptors, and that increases and improves their function. While amphetamine, for example, which is a TAAR1 receptor, trace amine receptor agonist, it causes dopamine to efflux out of the neurons into the synaptic cleft. So there you're releasing a stored up supply of neurotransmitters. And then after they're released, then they have to be restored. And so that's sort of a temporary effect where you're just spending the biochemical savings of your body in a quick manner. And so, I'm thinking about the racetams, or I'm thinking about these mitochondrial enhancers. I'm thinking about things that improve the functioning of various aspects of the brain and mitochondria and so forth without causing damage or even reducing the damage that is caused by normal physiological functioning.
Tell us about the creation process of Mitogen in particular. Let's talk about that one a little bit. We wound up with 6 ingredients in it. How many things were considered and ultimately discarded? What was your process there?
I wrote this long article last year about how acetyl acetylcholine works and one about how mitochondria work. And I did a lot of research, and I looked at a lot of different aspects of how the mitochondria function. And basically, as I went through the whole chain of mitochondrial reactions, basically how glucose or beta oxidation, which is how fat gets metabolized, produce energy in the cells, I was looking at each reaction along the way, and there's a lot of them. Just to get from glucose to pyruvate, there's many different enzyme reactions. And so I'm looking at each one of these reactions, and then I'm kind of looking through the research to see, are there any supplements, any nutrients that improve the processing of these various steps in the metabolic chain. And I would try them, and I would kind of see how my athletic performance was affected, my energy levels and so forth. There were a couple of things that I tried that I set aside. For instance, pyruvate is basically the end product of glucose metabolism, but right before it gets to the pyruvate dehydrogenase complex, which is what turns pyruvate into acetyl-CoA, which feeds into the citric acid cycle, powers the mitochondria. So it's this very long chain of steps to turn glucose into energy. It's like in the middle. It's the end product. And so I was thinking, okay, well, how about we add pyruvate to the supplement? So I was taking pyruvate, and it was sort of like when I would go running, I would have some extra batteries. But then if I wasn't exercising that day, if I was just sitting away coding at the computer, it would tend to make me gain a little bit of weight. And I think that was because it's the end product of glucose metabolism. So I nixed that one. Instead, I went a little further downstream, looked at the pyruvate dehydrogenase complex, and their vitamin B1, otherwise known as thiamine, and vitamin B5, otherwise known as pantothenic acid, are pantothenic acids providing the CoA part of the acetyl-CoA that comes out of that reaction. And there's an optimized form of vitamin B1 called sulbutamine that easily crosses the blood-brain barrier and increases the amount of vitamin B1 available for this reaction. So I'm putting these two together along with R-lipoic acid, which is a cofactor, and the pyruvate dehydrogenase complex. So we've got all three of these turning pyruvate into acetyl-CoA. And acetyl-CoA is what goes into the mitochondria, powers the citric acid cycle, and then that's the next step in energy generation. There's a few more. So then, there's all these steps in the citric acid cycle where acetyl-CoA is getting progressively oxidized. And basically what's happening is acetyl-CoA is powering the citric acid cycle and producing these chemicals like NADH, succinate. And these power these pumps. So basically it's pumping these H plus ions out in the inner membrane space so they can come back in through ATP synthase, which is sort of like the generator at like Hoover Dam, that's generating the electricity. And it's basically turning the ADP into ATP. And ATP is the good stuff. That's the unit of cellular energy that powers just about everything. And idebenine, it's a slightly tweaked version of coenzyme Q10 that helps these complexes, these pumps, function more effectively, even when they're not working as well as they should. And it's also been shown to act as a nootropic and help somewhat in cognitive impairment.
Just to step back a quick second, sulbutamine, what you mentioned earlier, again, in addition to helping with all this mitochondrial action, also has nootropic properties. That was one of the things I thought was really amazing when I was looking at the list of ingredients that wound up in Mitogen, is that these are all mitochondrial boosters in one way or another, but two of them also have nootropic properties.
And also, idebenine is also an antioxidant, which then prevents lipid peroxidation, which is a form of cellular damage. One of the things that's going on in the citric acid cycle is every once in a while a free radical escapes, unfortunately. And free radicals, they go off and they cause damage by oxidizing things they shouldn't. And idebenine helps to mop that up. So one of the things that I looked into but got nixed just because it's kind of too out there for Mitogen was methylene blue, which is a drug that's been around for 100 years. It was used to treat malaria in the beginning half of the 20th century. And there's actually a pharmaceutical company that's trying to develop it or a modified form of it as an Alzheimer's treatment.
I'm trying to think of anything that goes into the human body that is colored blue other than blueberries that's like a good idea. And there's not many of them.
Yeah. My aunt always told me, don't ever eat blue food.
Methylene blue is fishbowl cleaner, basically.
Well, that's one of its uses. It's a disinfectant. Like you have like your really nice tropical fish and they're getting all sick because you haven't cleaned your fishbowl in a while. And you make a hospital tank and you put a drop of methylene blue in there and you dip your very sensitive, very fragile, expensive tropical fish in there and then put them back in the tank and they're all healthy again. So
that one did not make the cut.
No, it's just a little too weird. And also, low-level laser light therapy apparently has some evidence that it's working at complex 4, which is this fourth pump. This is the pump that turns O2 into H2O. So that didn't make the cut. Then we have PQQ, which is a new, exciting mitochondrial energizer. It enhances mitochondrial biogenesis, which means making of new mitochondria.
And just to touch on that real quickly, it's not like a one mitochondria per one cell sort of thing. It's like there are loads of mitochondria, and it differs from cell to cell. Some cells, like neurons, have particular needs for even more energy than maybe some less active cells in other parts of the body. But mitochondria sometimes move around within the intercellular area. Sometimes they're stationary. There's really a lot going on with these guys.
Yeah, they go, like if the neurons are growing, they go and concentrate in the areas where they're growing to kind of help out, provide some energy, fill, the activity that's going on there. So yeah, mitochondria, there's lots of them, and they move around the cell. Also, there was recent research that suggested that PQQ can inhibit amyloid fibril formation. I mean, more research has to be done, but that was something that was interesting to me. Also, and finally, we have vitamin C, our old friend, an antioxidant preventing free radical damage, and it helps the electron transport chain function properly across almost all of the complexes, especially during aging. There was a study on that I referenced in my mitochondrial article. So there we have it. The Mitogen stack. Now, each one of these by itself is a great nutrient, and together they provide a large amount of energy, and it's not stimulant energy. You're not releasing a whole bunch of neurotransmitters.
You don't have a crash afterward, like you said, not dipping into your stores in an unhealthy way.
Yeah, this is how I kind of develop these things, is I think, okay, let's see, what's going on? Glucose is turning into this, turning into that, is turning into energy, and each step along the way, I kind of dig into PubMed and look at all these little cogs and wheels, and what's crazy about proteins is protein folding. Proteins are these nanotech awesome machines. I mean, they're incredible, and they're very hard to simulate in computers using protein folding, and that supercomputers have a hard time simulating how these proteins fold up, and that causes them to have certain properties. It's kind of one of the counter arguments to impending artificial intelligence with human-like capabilities, because these little machines, they're really complicated. What I'm thinking is, okay, how do we make these machines work better? And things that are usually toxic byproducts of metabolism, or they're usually things that get in the gears of these machines and cause them to work less well. I mean, that happens with like aging, or when people have hangovers, that kind of thing, is various issues with how these proteins are working. So these enzymes are working, and what I'm thinking is, okay, how do we make these work better? What substances make them function more optimally? That's what I'm looking for.
Smart Drug Smarts.
So thank you very, very much to Abelard Lindsay for taking the time for that conversation and breaking down his process and the origins of Mitogen, which I am really a huge fan of. And of course, to a certain extent, you can't take me seriously now when I say that, because it is a product I'm selling, but it is also a product that I'm putting into my own body. So hopefully that counts for a lot in the form of authenticity. And for those of you with shipments on the way to you now, I can't wait to hear what you think when you've gotten a chance to give it a try. Mitogen and its sibling stack Nexus are available at axonlabs.io. And if you can't remember that name for some reason, of course, you will find a link over there from smartdrugsmarts.com as well. One of the things Abelard and I talked about that didn't make it into the interview, but actually I thought was sort of an interesting little path that we ran down, is the actual word nootropics, which I'm very much of two minds on. There is the original dictionary definition. I don't think it actually is in the dictionary, maybe. But the guy who coined the term came up with 5 quite restrictive requirements for some theoretical chemical to be considered a nootropic. And they're kind of the things you would expect. Promotes neuronal activity, makes neurons more resistant to damage, excellent safety profile. We'll put a list of all of them on the site. But when you kind of look around in the web now, and increasingly when people are using the term nootropics in conversation, there's a much laxer definition. And you'll hear some things referred to as nootropics that really don't meet that definition. An example would be Adderall, which is certainly a cognitive enhancer. It can help people think better, but because of a safety profile and its potential for abuse and addiction, really doesn't meet the dictionary definition. And so we were kind of kicking around, what should the word nootropics mean? Is it going to be one of these things where whenever I say nootropics, I need to say it kind of like with an asterisk and say, okay, this is the formal version of nootropics versus the colloquial version of nootropics? But I really liked Abelard's distinction that he made early in that interview, saying that to him, a nootropic is something which has cognitive enhancing properties, and that whatever its mechanism of action is, it's not something which is depleting your mental or physical resources. It's not sort of borrowing ahead biochemically and going to cause a crash or a depletion or something that you need to spring back from. If you kind of think of a lot of recreational drugs, they might do something like release a lot of dopamine or a lot of serotonin and have some really positive short-term effects, but you're kind of taking out your allowance early, and then there's not going to be any allowance for a while after that. And you need to take some time off or resupplement just to get back to your baseline. And Abelard's definition is more like something that if you were looking at kind of the XY curve of cognitive performance, there would be a jump above the baseline and then sort of a smooth curve back down towards the baseline, but never dipping below. And I think that's actually a pretty great way of thinking about sort of a middle-of-the-road definition of what a nootropic is. And I still feel myself vacillating a little bit about how we want to make use of that word if I want to distinguish between nootropics and cognitive enhancers, but that's kind of the definition that I'm leaning towards going forward. Anyway, enough of that, on to the ruthless listener retention gimmick.
Smart Drug Smarts. Ruthless listener retention gimmick.
If you've ever been walking down the street in a busy city, in an unfamiliar neighborhood, feeling a little bit weird because you're not so sure about the people that are around you, one of the things that you're always kind of concerned about is the people that are walking around that are just muttering to themselves, talking. They're not on a cell phone, they're just talking. And we tend to think sometimes for good reason that these people might be crazy, but they might also just be looking for something and trying to talk themselves into a better cognitive state to find what they are looking for. It turns out that talking to yourself has been scientifically proven in at least one study to help you find things. If you're looking for something, say your car keys, talking to yourself about your car keys makes you more likely to effectively find your car keys. Basically, it helps dial in your visual filters for keys. Now, if you wander too far off target, if your self-dialogue starts going too far off track, you start blaming the person that you were with earlier who distracted you, and then you forgot your keys, and you start thinking about how that person really messed everything up, and you never should have gone to that movie with them, and blah, blah, blah. Then, not surprisingly, that can actually mess up your visual tracking and make you less likely to find your keys. But if you kind of keep your self-talk focused on the subject at hand, this actually helps your visual processing better than if you just stay mum and say nothing. So if you find yourself looking for something, and we all do sometimes, do not be shy about talking to yourself a little.
Smart Drug Smarts, the podcast so smart, we have smart in our title, twice.
Okay, so you heard it. That is the entire episode. Thank you for hanging around until the very end. I heard something on a podcast recently that I just loved. So I've got a friend named Harry Duran. He does a podcast called Podcast Junkies that I was actually lucky enough to be interviewed on in one of his early episodes. But I was listening to a recent episode, and he does a thing now where when people listen to all the way to the very end, he gives them a little tag phrase to make a hashtag and tweet that at him so he knows that, hey, at least this one person listened to the very end of the episode. I thought that was really awesome. So if you've made it all the way here and you are a Twitter person, if you want to tweet something with hashtag StaySmart, I would really appreciate that. As you know, I'm also a big appreciator of people leaving reviews on iTunes for the podcast. If you enjoyed it, that's a great way of helping us out, keeping us up in the iTunes rankings so more people can find us. And of course, just good old-fashioned telling people, hey, this podcast is kind of cool. Next week, we've actually got a great interview. It's already recorded. We're going to be talking about some pharmaceuticals' effects on moral decision-making. And we're going to learn about the term hyper-altruism. That'll be in episode number 86, coming at you next Friday, when I will be back at you with an unwavering commitment to helping you fine-tune the performance of your own brain. Until then, have a great week and hashtag stay smart.
You've been listening to the Smart Drug Smarts podcast. Visit us online at www.smartdrugsmarts.com and subscribe to our mailing list to keep your neurons buzzing with the latest in brain optimization. Smart Drug Smarts should be listened to for entertainment purposes only. Although some guests on the show are medical doctors, most are not. And the host is just some random guy. Nothing you hear on this podcast or read at smartdrugsmarts.com should be considered medical advice. Consult your doctor and use some damn common sense before doing anything you think might have a lasting impact on your brain.